बिल्कुल। अब आपको लाना जिम्मेदारी है राजेश सर।
हाँ, लाएंगे लाएंगे सर नेक्स्ट टाइम। आप आ गए सर डिपार्टमेंट में?
मैं नहीं है डिपार्टमेंट में। मैं बस, मुझे था 10 बजे है, तो
हाँ
फिर मैंने देखा 9:30 है, तो मैंने सोचा कि
हाँ
शुरुआत
हाँ
यहाँ से करके फिर मैं पहुंच जाऊंगा
हाँ
डिपार्टमेंट।
हाँ,
है ना।
ठीक ठीक।
वो 10 और 9:30 का कंफ्यूजन, तो बेटर ये था कि रास्ते में दौड़ लगाते, उससे अच्छा ये कि घर से
ना ना,
शुरुआत।
सही किया आपने।
आप तो डिपार्टमेंट में ही बैठे हैं हमारे।
हाँ हाँ, मैं शर्मा जी के साथ।
हम्म।
तरुण,
सर स्टार्ट।
इंट्रोडक्शन के लिए कौन?
ओके सर, ओके सर।
आज एग्जाम होगा ना?
गुड मॉर्निंग एवरीवन।
Good morning.
गुड मॉर्निंग सर।
It's my pleasure to introduce today's morning session speaker, Dr. Komal. Dr. Komal, an assistant professor in the Department of Mathematics at the School of Physical Sciences, Doon University, Dehradun, Uttarakhand. Dr. Komal earned his PhD in Applied Mathematics from IIT Roorkee with a specialization in reliability analysis of real-time industrial process using fuzzy logic. Additionally, he holds a master's degree in applied mathematics from IIT Roorkee and a bachelor's degree in PCM from CCS University, Meerut. Dr. Komal's research interests are diverse and impactful, covering areas such as multi-criteria decision-making, fuzzy reliability analysis, and soft computing. His significant academic contributions have earned him recognition, including the prestigious Governor's Award for Best Research in 2018. He has also successfully cleared competitive exams like NET JRF and GATE. With over a decade of teaching and research experience, Dr. Komal has held various academic positions at esteemed institutions such as HNB Gadwal University and the National Institute of Technical Teachers Training and Research, Chandigarh. In addition to his teaching and research roles, Dr. Komal has also contributed administratively, having served as the warden of Sipalik Boys Hostel and assistant coordinator of examination at Doon University. Dr. Komal is an active member of, sorry, multiple professional organizations, including the International Association of Computer Science and Information Technology and the Indian Society of Industrial and Applied Mathematics. His research is widely published and he is a frequent speaker at both national and international conferences. We are honored to have him here today, and I am confident that his insights will greatly enrich our understanding of topic Introduction to Multi-Criteria Decision Making with Application. Please join me in welcoming Dr. Komal. Dr. Komal, sir.
Thank you, Dr. Saab. First of all, I would like to thank the organizers for inviting me in this event and giving me an opportunity to share my research area with the candidates of this event. And again, I am thankful, Shivraj sir and the head of the department, Kesh Kumar sir, and all the Rajesh sir also for giving me this opportunity. So I'm now sharing my screen. Is it visible?
No, sir.
डॉक्टर साहब आप शेयर कर सकते हैं।
हाँ, मैं शेयर कर रहा हूँ। Is it visible now?
Yes.
हाँ, yes, it's visible. Please follow.
Okay. So the topic of my talk is Introduction to Multi-Criteria Decision Making with Application. And the brief overview of the talk is, first I'm going to discuss what is MCDM, then some basic related concepts, including maximizing deviation method. Then I will discuss what is
आप चलेंगे ना
Archimedean T-norm and T-co-norm, which is denoted by ATU based intuinistic fuzzy VASPAS method. And then I will take an application. This talk is basically based on my recently published paper in 2023, which is in Applied Soft Computing Elsevier. So what is MCDM? So first of all, we are having what is the idea of decision making, because MCDM is related to decision making. So do you often get overwhelmed when it's time to make decisions? Sometimes we make decisions on a very quick basis, or sometimes we have certain time to take decisions. So most of the days we face decision big. Most of the times we are trying to face this type of problem. Sometimes the decision making problem is big or small. Similarly, the challenges may be big or small depending upon the problem. But how can we approach the process with confidence and clarity? This is the question. So we will try to give some kind of idea with based on this MCDM. So what is the broad structure of this this decision making process? We can resolve any kind of problem by following these steps. First of all, identify the decision making problem, then gather the relevant information, and then identify the alternatives. Here alternatives means that may be either solution approaches, either for example, you are having multiple options. For example, if you are buying a mobile from the market, then you are having certain options. So those can be understood like alternatives. Similarly, weight the evidence, choose among the alternatives, and then take certain action and review your decision. So this is the 7 steps strategy, and this is also shown by this graph. Now, what is multi-criteria decision making? So multi-criteria decision making has grown as a part of operations research concerned with designing computational and mathematical tools for supporting the subjective evaluation. Subjective evaluation means the evaluation which are based on generally languages of performance criteria by decision makers. Similarly, MCDM tools are generally applied in arriving at an optimum decision when faced with multiple alternatives having multi-conflicting and non-commerciable decision making. Generally, criteria can be classified into 2 categories. One are based on the cost criteria, which are not favorable in your decision making support, and the second kind of class is the benefit type of criteria, which are favorable in your decision making process. So these are the 2 broad categories. Whenever we are trying to solve any kind of decision making problem, generally we will take certain compromise between these 2 type of criteria, and this compromisation is done with the help of normalization process. I will discuss it later on, what is the normalization process, because one type of criteria is going in downward direction, another one criteria is going in upward direction. So we have to take certain levels so that they can reach in the same direction. So this can be done with the help of normalization. And then the third point is the technique is well known for solving complex real life problems due to their intrinsic ability to judge diverse alternatives with reference to various decision criteria in order to choose the best alternative, because the ultimate goal is to select the best alternative. So what are the common terms generally used in MCDM? The first term is decision maker, where experts are assigned to weight tasks given. The second term is the goal, which what DM wants to achieve. The third term is criteria, or sometimes we are using criteria or attributes. The alternatives to be compared with and evaluated. The fourth term is alternative, the methods or decisions that are to be chosen or ranked. And last one is the weights, representing the relative importance of the criteria. Because to resolve any kind of decision making problem, generally we want to the first task is to find out the weights of the criteria. Kis criteria ko kitna weight dena hai. So this is very important. Now we can broadly classify our MCDM approaches into 2 categories. One is MADM, that means multi-attribute decision making, and the second one is multi-objective decision making. MADM generally can be simply understood by assuming that whenever your decision making space is discrete, then you can use MADM, and when your decision making space is continuous, then generally we will use MODM. So this is the broad difference. Now, some of the applications you can see in healthcare. Recently, COVID-19 when done, then lots of papers have been published in this by using MCDM. Similarly, in energy sector, engineering and production sector, career and jobs, supply chain management, organizations and corporate system, education, transportation, civil engineering, finance and economics. Recently, my paper in 2000 engineering expert systems and in Elsevier, which is based on this COVID-19 problem. So you can I will also show you